Hello viewers, tutorial 9 question 7. Find all turning points of the following functions and state the nature. So we want to know where there are maxima and minima of the functions, and we want to know whether each one is a maximum or whether it is a minimum. Okay, so to work out turning points, first thing we need to do is differentiate, and once you've got the derivative, make it 0 and solve the resulting equation. So 5x squared differentiates to 10x plus 7x differentiates to 7, and then we're going to solve that thing. So 10x equals negative 7, and then dividing by 10 gives x equals negative 7 over 10. So we have the x value where there is going to be a turning point. Now we need to work out what the y value is. So the y value, because we've got the x coordinate, we need the y coordinate. So the y coordinate is going to be y of minus 7 over 10. We need to substitute into the original. So we get 5 times negative 7 over 10 squared plus 7 times negative 7 over 10 minus 3, which gives us negative 109 over 20. So we have that there's a turning point at x equals negative 7/10 and y equals negative 109/20. Okay, so to work out whether it's a maximum or minimum, we don't know which it is yet, we need the second derivative. So the first derivative was 10x plus 7. Differentiating that gives us 10. So we get a positive answer from the second derivative, which tells us it's a minimum at the point x was negative 7/10, y was negative 109/20. So that's the point that we have for a turning point at 5x squared plus 7x minus 3. Okay, part B, same steps, differentiate. So if we differentiate this function, we get 3x squared minus 12. Make that equal to 0 and solve. So 3x squared equals 12. Divide that through by 3, we get x squared is 4. So therefore x is going to be plus or minus. So two solutions. We need to take the square root. Square root of 4 is 2. So two solutions are 2 and negative 2. Let's also take that second derivative before we go any further. So 3x squared minus 12 was the first derivative. Differentiate that twice, we get 6x. So 6x is the derivative of the original function. Now for each turning point we need to find y, and we need to find whether it's maximum or minimum. I'm expecting one of each here because it's a cubic. Okay, so we've got a turning point at x equals 2. So when x equals 2, what's y of 2? That will be 2 cubed minus 12 times 2 minus 4. So 2 cubed is 8 minus 24. So far we have minus 16 minus 4 is negative 20. And what about the second derivative? So y double dash of 2. So we need to substitute 2 into the original as well. So we get 6 times 2 is 12. That's a positive answer, so it's a minimum at x was 2 and y was negative 20. Now we also need to deal with x equals negative 2. So when x equals negative 2, y of negative 2 is going to be negative 2 cubed minus 12 times negative 2 minus 4, which is minus 8 plus 24. Minus 4, so we get 4 there. Do we? We get 12. Okay, so we get turning point 12 will be the coordinate, and y double dash of minus 2 is going to be 6 times minus 2, which is negative 12. So we get a maximum because it's a negative value of the second derivative. Maximum at, this is going to be negative 2, positive 12. Okay, And we have one more function to do. So we have y equals x minus e to the x plus 10. Differentiate that. We get y dash as x differentiates to 1, e to the x differentiates to itself, 10 is just a number, and we make that 0. So therefore, if we move the e to the x to the other side, we get e to the x equals 1. We could take the natural logarithm of each side, or we know that e to the 0 equals 1. Comparing these two equations tells us that x equals 0, there will only be one turning point. So y of 0, we'll substitute 0 into the original. We get 0 minus e to the 0. So 0 minus 1, which is negative 1 so far, plus 10 is 9. And what's the second derivative going to be? Y double dash is 1 minus e to the x was the first derivative. Differentiate that. We get negative e to the x. And now we can substitute 0 into that. We get negative e to the 0, which is negative 1. That is negative, so it's a maximum at the point x was 0 and y was 9. Okay, thanks for watching. Over and out.